Hey guys, so our 6th grade math lesson for the week is going to be over greatest common factors, or GCF. So right up here you can see that it says factors shared by two or more whole numbers are called common factors. The largest of the common factors is the greatest common factor, or GCF. You will commonly see GCF, and so that is an acronym that you will need to know for greatest common factor. Right here it gives you some examples of finding the factors of two different numbers. So you find the factors of 24 and the factors of 36 to find their greatest common factor. And so in red, you can see all of the common factors that these two numbers have. Because there are so many of them, you need to highlight them in red or circle them until you find the greatest factor that they have in common. And so, for example, in this one, it is 12. Then right down here, you can see the greatest common factor of 24 and 36 is 12. There are a couple of ways that you can do this. That first method was just listing the factors. This might be the easiest one for some of you, and that is absolutely okay. After I go through all of these, I will show you some examples, and you can pick the method that works best for you. So the first one is to list the factors. So it gives you two numbers, 16 and 24. You list the factors of 16, you list the factors of 24. They have the common factors highlighted in red. The way that I am going to show you is I'm going to circle the ones that they have in common. And so then they found that the greatest common factor was 8. Right down here, you can use prime factorization, which we talked about last week. So you can see that they're finding the GCF of 3 different numbers. So they grab the prime factorization for each number. They find the common prime factors, because with prime factorization, you end with the prime factors. And then you find the prime factors common to all of the numbers. So in this case, we need to have the common factors in all 3 numbers. So you can see that the common factors are highlighted in red. They have 2 2's in common. As you can see, there's a list of 2's here and a list of 2's here. So to find their GCF, because they have 2 2's in common, they're going to multiply 2 times 2 to get the greatest common factor of 4. And then right down here, they are, again, finding the greatest common factor of 3 numbers, 12, 18, and 60, but they are using the ladder diagram. You're kind of introduced to this last week when figuring out prime factorization. So you list all 3 of the numbers right here, and you put them into boxes, and then you find a number that can be equally divided into all 3 numbers. So, for example, they started with 2. 12 divided by 2 is 6, 18 divided by 2 is 9, 60 divided by 2 is 30. Now, 6, 9, and 30, they each have a number that goes into them evenly. That number is 3. So 6 divided by 3 is 2, 9 divided by 3 is 3, 30 divided by 3 is 10. How you know you are done is there is not a common divisor amongst these. The only number that can go into 2, 3, and 10 evenly is 1. So that is how we know we are done. And so you look over here, you divided by 2 and you divided by 3 for all of these numbers. So just like up here in prime factorization, where they multiplied what they had in common, they did that same thing down here. So they took the 2 times the 3 to find the GCF of 6. Now, if you are trying the prime factorization or the ladder diagram method and you are wanting to check your work, your best bet would probably be to list the factors. This might sound like a little more work because you have to think about every single factor of the numbers that they give you, but that is a great way to check if you did these 2 strategies correctly. So I am going to pull my whiteboard over and I am going to show you an example of all 3 strategies. So for the first one, we have 18 and 27. I'm going to just list the factors to find the common or the greatest common factor that they have in common. So I know there's 1 goes into 18, I know 2 goes into 18, and I'm going to keep these in numerical order so that I am able to easily see what they have in common. I know 3 goes into 18, not 4, not 5, I know 6 does, not 7 or 8, but I know 9 does. 6 times 3 is 18. 9 times 2 is 18, and 1 times 18 is 18. So I know I am done. For 27, I know that it's 1. I know that it's 3. 9 and 27, because 3 times 9 is 27, and 1 times 27 is 27. So let's go ahead and circle what they have in common. They have 1 in common, they have 3 in common, they have 9 in common. That is all I see that is in common, so I'm going to go with the largest one. So the GCF for these numbers is 9. Okay. Now I am going to come down here and do the prime factorization method with the numbers 10 and the number 35. So for 10, I know that 2 times 5 is 10. I know that only 1 in itself goes into 2, so it's prime, and same thing with 5. So I am done here. So that is my prime factorization for 10. Let's do 35. I know 5 times 7 is 35, and I also know these are both prime. So the prime factorization of 35 is 5 times 7. Now I need to figure out what they have in common. The only thing they have in common is 1, 5. I'm not going to multiply these together like in the last example because there is only one of them listed for each of them. So my GCF of 10 and 35 is going to be 5. Last but not least, I am going to come over here and do the LAD method with 3 different numbers. So to start off, I need to find a number that goes into 15, 30, and 60 an even amount of times. So I know that 5 goes into all of these. I know that 15 divided by 5 is 3. I know that 30 divided by 5 is 6. And I know that 60 divided by 5 is 12. Now, in order to tell if I need to keep going or not, I need to know, is there a number that goes into 3, 6, and 12 an equal amount of times? There actually is. So I'm going to write that number over here. I know it is 3. I know 3 divided by 3 is 1. I know 6 divided by 3 is 2. And I know 12 divided by 3 is 4. Now, to see if I need to keep going, I need to think, is there any number that goes into all 3 of these digits? My smallest one is the number 1, so I know that I cannot go any farther. So I over here have 5 and I have 3 because these are the 2 digits that evenly went into all 3 of these numbers. I am now going to take those and multiply them. 5 times 3 is 15. So I know my GCF of 15, 30, and 60 is 15. Now 15 goes into 15. I know 30 goes into, or 15 goes into 30, and I know 15 goes into 60. And again, if you are unsure when you finish with this method or the prime factorization, go ahead and list those factors to check your work and make sure that you got it correct. If you have any questions, please feel free to reach out to me through Google Classroom.